but I'm sure that wasn't the case. Yeah, so my name's Gary Atkinson. So I'm the program leader for this degree course. Okay, I've been here for quite a long time, but I've only been running the program myself as the lead role for about half a year. So I'm quite new to that side of it. Um, and as I think perhaps Vincent said, this particular program, it is accredited by the IET, the Institution of Engineering and Technology, which means that it includes all of the essential material and skills that you would expect for an engineering degree. Okay, so it's ticked off that box from the start. Okay, so first of all, I want to talk a little bit about robotics in general and why you might want to do that, because some people have actually the wrong idea of what robotics really is. And from the people I've spoken to over the last few years, people tend to have one of three views about robotics. The first view is they think of robotics as machines that do lots of building, okay, especially in your part of the world, okay, in China, throughout China, obviously lots and lots of manufacturing. That's the first preconception. The second is some sort of Terminator style robots that's going to destroy the world, okay, laser guns and things like that. And the third is some sort of like fun toy sort of robotics, okay? So these are the things that a lot of people think about when they consider robotics. And actually, the funny thing is that the reality is actually quite similar in some ways to these preconceptions, because there is a lot of robotics in manufacturing, both in the East and the West countries. And there are concerns these days about robotics in things like a warfare. And one thing that's interesting about this program that I run is we don't pretend that that's not the case. Okay, it's very important to consider the ethics of robotics and both the good and the bad things that it brings to the modern world. Okay, so we will be talking about that on this program. But of course, we don't want to focus on that. That's just one thing we need to be aware of, because there are other things, great things that robotics brings to the world. So, for example, here are a few things that we've done research on here in the Bristol Robotics Laboratory. So the first thing, for example, is the use of generation of clean energy. So on the screen there, you can see my colleague John, and he and his group managed to build a toilet that when you can take a urine and generate a small amount of electricity from that toilet. Okay, and that's amazing for sort of like poor remote communities. And that toilet you can see there is in a small poor village in the country of Uganda in Africa. Okay, it doesn't generate enough electricity to power a city, so you can't put these in Hong Kong and expect all these amazing lights of the city to be powered. But to power the light of the toilet in a remote place, it can do that. And then an area that I work in actually is in computer vision and digital imaging. And this is an example of some work that we did here about agriculture. So that I can just can you see my pointer? Yeah, okay. So this is a weed, like a plant that we don't want in a field where we're trying to grow some useful crops. And what happens a lot in agriculture at the moment is to destroy all the weeds, we just apply a weed killer across the whole field. That's really bad for the planet, and also is bad for some of the other plants. So in this project, what we did was we took a tractor that goes across the field and we put a camera on the tractor, which records a video of the ground when it moves across the field, and then it uses a latest AI technology to detect the weed, and it will kill the weed. It will just apply the weed killer to that little bit instead of doing it across the field. And one of the most important application areas of robotics and AI in the 2020s and moving to 2030s is in this area of of agriculture. And again, particularly important in your part of the world, I mean, the whole world, but especially in China, with obviously such a huge population, and areas of China is so densely populated that it's really, really important to be optimized in terms of the food generation. And it's not practical for people to do all of this work, so we get robots now to do some of it for us. And then the other big area at the moment is in medicine and assisted living. And that's not my personal area, but my colleague, for example, built this prosthetic orthotic device to help someone with their arm to get some feedback because they'd lost the sensitivity of their fingers, so they can start to feel a bit more again like they used to before. I think maybe it was accident. I can't remember exactly. So we can see that these are the reasons why I'm interested in robotics. I'm aware of some of the dangers that robotics brings, and it's important that we're familiar with that, but also these amazing things it does for people and for the planet. So it's a great time, actually, to work in the field of robotics and AI. It really is. And the other thing that I find quite interesting about robotics is that it's got lots of applications and it draws people with lots of different skills. So me, for example, I actually have a degree in physics, and then I did a PhD in computer science, and then I moved into robotics and engineering. But other people that I work with are from psychology, for example, from mathematics, electronics, and so on. And also, as I said, lots of different applications. I'm not going to talk about all of these applications today, but I've already mentioned agriculture and sort of defense technology, security, I think, and transport is a big area at the moment as well as driverless cars start to become popular. So lots of different people, different backgrounds, and lots of different application areas. That's one thing I love about robotics. Now, as far as the particular program is concerned, which I guess is why you're here today, this is just a table that contains the modules that we include. There's not enough time today to talk about all of them, but what I would just say is if you look at this bit on the left, these modules here, these are modules that we share with other programs. So, for example, we have a mechanical engineering program here, an aerospace engineering, electronics, and automotive. Okay, so we've got several engineering programs. And for these modules, what we do is we bring them all together. So they're big modules because, of course, many of the techniques that you need for mechanical are similar to those from engineering. So we bring everybody together so you get to see people and other students from different backgrounds to learn these common skills. And then moving to the right-hand side of the diagram of the table, we have more of the technical skills for robotics. Some of them obvious, like programming and electronics. Obviously, we need to be good at that. Others maybe you're not quite so familiar with, such as signal processing or my field of machine vision, which is about AI and extracting information from images and things like that. So that's how the structure is. If you have any questions about the structure or particular modules, you can send me an email maybe, and I can find out for you after this session. One thing that we try to do in the program, and I in particular trying to bring this, is to draw the balance between understanding the basic theory in like a more of a traditional academic sense, but also being able to understand the application areas, especially in robotics, and to do things in practice. So, for example, with AI, which is such a big area these days, we all know that, it's important, first of all, from the top of the diagram, that you have a good understanding of the theory, the basic theory. And I feel really strongly about this because actually a lot of people these days, they're saying, oh, all that really matters is we know how to use these tools. But actually, the world is moving into an age where AI is becoming popular in all sorts of areas of life. And it's important that people that have studied the area understand the basics. And in some ways, I think even the public should understand this. And I'm actually writing a book about this now to help people understand the basics of AI as well as science more generally. So it's important to cover some of the underlying theory. But at the same time, the program is designed with employability in mind, okay, because we know that, of course, you want to come here to UWE Bristol and do a degree and then get a good job about it. Okay, I'm not stupid. I know that's the main motivation. So therefore, we need to make sure that you come out of the degree being able to actually go into industry and then apply the various techniques straight on, okay, not without any more training, okay. So that's what we're trying to do here, is to draw a balance between these different aspects of the degree. So I picked out a few modules just to give you an idea of what to expect while you're here. Okay, so the first module I've picked out is about engineering practice. This is one of the modules I mentioned where we bring all of the students together from different engineering subjects, which is why you can see in this diagram here, there's lots and lots of people, although I've been to Hong Kong, so I know in Hong Kong you maybe look at that and you think there's not many people, okay? You're used to people everywhere, okay? But in the UK, this is a lot of people, okay, to have in one room. So we bring everybody together, working as teams on little projects, which is important for engineering, okay? Because if you want to be a professional engineer, yes, you need to be brilliant at maths, but also you need to work well as a team and on project work, okay? So that's what this module is all about. And I've just borrowed this slide from my colleague. So this shows us how we approach major engineering projects from a project management point of view, okay? So when you go into industry after, you can say to your employer, I know how to manage a project. I know how to work as a team. So that's one thing that's quite new to the course. And then the other end of the scale, we have more technical modules. So this is perhaps the sort of thing that you might expect to see on a robotics degree. So we have these robots that we can design and build. And to help to train the robot using modern methods of machine learning, we put it in this maze. So every year we have a competition to see if you can get a robot to successfully work its way through this maze to the finish. And what I like about that as well is, just moving on to the next module, is it allows us to consider all aspects of robotics, quite a big field these days, okay? So what we do for this related module is we take some existing hardware, in this case it's a robotic arm, and we do some design work on it using computer-aided design to add an end effector. We also design some software to control the robot arm. We design a user interface for the user to use at a later date. And then we do electronics, okay, to build extra components to it. And then we put all that together. In this particular case, it's just a demonstration of a robot to place golf balls. Okay, obviously, it's not the most useful application, but it demonstrates how you can bring together all these different skill sets, okay? So again, we call it a systems level approach, okay? So it's not just about learning each of these things separately. It's about putting them all together to make something that can do something useful. Okay. And then another example module, I think this is the last one I'll talk about, is using some more modern approaches from machine learning. This is actually my module about computer vision and machine learning. So I teach this module by way of like a silly example, but then we apply it to do something really useful. So these cats here, these are my cats, and this is my neighbor's cat. So I've trained a computer vision algorithm that can recognize these cats. Okay, so it's not something that you maybe expect to do in a degree. But I use this as a simple example that we can all understand. Okay, we all know what a cat looks like, and we all can say, well, how can we recognize this cat from this cat? So what I do is I show how we can use some previous research here. Okay, so this little bit of the diagram is using a previous AI model that can recognize lots of different classes of objects. And then I'll show how we can then apply a technique called transfer learning to take all this hard work that someone else has done and then just retrain it to then be able to recognize a cat. And when you've done that, that's understanding the basics with a fun example, we can then do something a lot more useful with this idea, okay? So in my module, for example, I use it to teach a computer to recognize handwritten characters, okay? So if I actually just use it for numbers, actually, from 0 to 9, okay? But in theory, you could use it for any letters. And of course, in Cantonese, you don't really have letters. So that would require a lot more work to train the algorithm to recognize a Cantonese writing. But the technique is the same. It's just different training process. And then in the final year, like in most degree programs, we have a project that you'll do. And you can choose the project, and it can take many forms. But we, or I and you, if you come here, are based in the Bristol Robotics Laboratory, which is a shared research space with the University of Bristol, okay? It's actually the largest robotics laboratory of its kind in Europe. So we have access to lots of great people here with different areas of expert. So I mentioned my background is in computer vision and image analysis. So I had a project student last year who did this work on the left, which is about using computer vision to detect and count flowers, okay? Why were they interested in that? Because we live in a changing climate, and they wanted to develop a system that can automatically count the number of flowers of a different type over the years to make sure that they're not declining, or at least to count that. And then another project I supervised is this one on the top. Just down the road from here is the National Composite Centre. They work on carbon fibre composites and work with lots of different universities. So this person did a project, there's industry-focused project that looks for defects in carbon fibre parts, okay? That was a big thing to work on because major companies, which are up the road in the other direction, and Bristol is famous for aerospace engineering. So we've got Airbus just down the road, and Rolls-Royce are just down the road, as well as GKN, major international companies. And Airbus in particular have been doing some work with me about trying to find flaws in their components. Okay, so they helped with that project to get that set up. In fact, can you see that behind that thing there behind me in my office? That is the thing that he built that does just that. Other people, of course, in different areas. So we talked about assisted living earlier. That's a big area for robotics at the moment. So we've got a whole room just down the corridor from here, which is set up like somebody's home, and people with an aging population, a lot of old people now, and we can't necessarily afford for them to stay in hospital, so we want them to live at their home. So we're working on different technologies that allow them to work from home more easily. Okay. So when we do final year projects, if you want to do a project in really theoretical area, that's fine. I'm a big fan of that. You can do that. But normally what we like to do is to draw upon the latest developments in robotics, like assisted living and agriculture, and we'll do a project with that, making the use of our big laboratory. Well, how long have I got? Can you remind me what time? Is it 1:45? What time did we say I'm talking until?
15 more minutes, 15 to 20.
Oh, okay, fine.
Yeah, but if you want to share more, I think, the audience would love to hear more.
Okay, well, 15 minutes is perfect. Yeah. Okay, just so I know whether to speed up or not. So a few other things. So we talked about robotics generally, okay, and why I'm in particular keen on robotics and why I think you should be as well. And I've talked a little bit about the program. There's a few other things worth sharing with you about where we work here in the Bristol Robotics Laboratory that's maybe unique to this course. So the first thing worth mentioning, this room here you're looking at, okay, it looks a bit like what you would expect in a robotics course. But the reason I'm showing you this is that that particular room is effectively ran by students with its own dedicated technician. And you can do basically whatever you want in there, okay? You can use it to help you with your course, yeah, no problem. But also a lot of people do things in there like start a business, okay, which I'll talk about in a moment, and to try out new ideas for their little business. We also have some employers that will set up a little competition. So they'll set up a competition and then the students can work in this room to do it in the competition to see if they can win it. And if they win it, they'll get a little prize. And that's, of course, good for their CV and therefore employability. But even if they don't win the competition, it's good experience and it gives them good contact with the companies. And often the students that engage in these competitions are offered employment directly after. And that might not apply to you because, of course, you're in Hong Kong. Maybe you want to go back to Hong Kong, but it's always good to have good contacts at big companies, I think. We also have like speakers and things like that from other universities that will come and give a talk for this. Now, I mentioned business. A lot of students, and I don't have the figures exactly, but I would guess maybe 80%, maybe 90% even of the students that do robotics, they're not doing it because they're interested in business. Okay, and I'll be honest, I'm not really, I think of myself as a scientist, not a businessman. But for those people that are interested in the business side of things, we have just around the corner, the incubator. So I know Kathy likes incubators, don't you? So the incubator is where we have very small businesses, so maybe only a few people in the business that come up with a new idea and they want to develop the idea. Okay. We also have an area called the future space, okay, which is for more established businesses, but still only maybe 10 or so people in the business that have a really good idea and they want to try it out. And some of these businesses become very, very successful. Others, they don't work out and then they go on to do something different. But what's really good about it, thing is, a problem with business, of course, is that you never know if it's going to work until you try it. Without this facility, people, they might have a business idea and they invest a lot of money into it, a lot of time into it. Maybe they get a loan, perhaps off their parents or from a bank. And then if it doesn't work, then they've lost a lot of time and effort. The good thing about this is, if it doesn't work, you've not lost anything because we've got special financial and technical support for you to try out the ideas. Okay, so you can do that for free in the incubator. So this space behind that glass there is where you can try out your ideas, see if you get some momentum, see if the idea works. And if it does, then you make a business out of it. If it doesn't, then it's only a small loss, okay, compared to a major loss if you'd invested lots of time. Yeah, so like I said, most people, this is not exactly why they want to do robotics, but for a few people, if they're interested in the business side, then this is a big benefit for them. So as I mentioned earlier, the Bristol Robotics Laboratory is a huge laboratory that we share with the University of Bristol. We've got lots and lots of different expertise. So let me just show you a few examples. So we've done some work on driverless car here. It's quite some famous work. I know everybody interested in driverless car throughout the world, wondering when driverless cars are going to be all over the place. Yeah. And knowing the area myself, I can tell you that 99% of the technology is really in place now, but that last 1% is the hardest 1%. And I tried the driverless car myself, and the hardest bit, I guess, is when the driverless car finds itself in a situation that it's not seen before. Yeah, we as humans still are superior, and so for now we are able to decide what to do in a certain situation. But the hard bit is when the driverless car bing makes a noise, it goes bing, 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 and then you have to take manual control. That's hard because maybe you've just been sitting chatting for the last 10 minutes and all of a sudden you take over the driving. So these are the problems that some people don't think of when they think about these technologies. It's more psychology than sort of technology. Yeah, so that's something that we contributed to here. I've already talked about assisted living for elderly people and machine vision, which is my area. AI, of course. This thing, a lot of the work we do is, but we call it biomimetic, which means it's trying to do a similar thing to what happens in nature. So this robot, for example, can you see these little strands? These are, we call these whiskers. Okay, so that's inspired by animals that have whiskers. Okay, the good thing about this is it allows us to touch, for the robot to touch something, but without really moving it. It's like a whiskers on a cat. Okay, yeah, if the whiskers touch a wall, then it doesn't really disturb the wall, but the cat knows that it's there. So we try to get inspiration from nature in a lot of the work that we do, and so on. But there's not enough time to do all of these things. Don't read all this. The only reason I've included this slide is just to show you how vast we are in terms of the application areas, from agriculture to other things. And then the destination. So Kathy asked me when I was preparing this talk to include some of the destinations where people go after they graduate from the robotics course. And actually, that's quite a difficult question for me to answer. So I had to look back over where people have gone. And as you can see, they go to many, many different places. So often they'll go to further study for PhD or for research in a different university. So I've not mentioned all of them here, but University of Glasgow, University of Nottingham, which is, by the way, where I'm from, Nottingham. Imperial College London's obviously a famous university. But outside of academia, let's go to so many different places. Dyson, I don't know, is Dyson well known in Hong Kong? Yeah, okay, right. So Dyson is the main premises for Dyson is close to Bristol, actually. So a lot of those people that get really top grades here have gone to Dyson and then go on to get a very, very high salary, higher than I get, for example, because Dyson, they're very selective about who they employ. I mentioned earlier Rolls-Royce, just up the road, Thales, the big engineering company, National Composites just around the corner. These are perhaps some of the more obvious choices that people go to. But I think what this shows is that with a degree in robotics, especially as we see AI becoming more and more popular, there are a great many opportunities. So it's actually a hard question for me to answer where people go because they're so broad. Especially because also it's a numerate discipline and employers like people with good mathematical skills, good analytical skills as well, which is why some of our students have gone, for example, to HSBC. Yeah, I'm sure you know HSBC in Hong Kong. I don't need to tell you about them. So lots of different possibilities that this takes you to. Outside of study, a few things worth mentioning. We do have opportunity for placement years. So you do 2 years and then you go into industry and then you come back for the final year. As international students, that sometimes is a little bit more complicated than for home students, but it is possible. So but if you're interested in it, we can talk about that another day. We have lots of things like volunteering opportunities, like all universities do. We've got good partners. So I mentioned earlier Rolls-Royce and nearby and so on. If you're interested in cars and motorsport, we get involved in what's called the Formula Student, which is a competition in the UK where students from different universities, they design and build cars, like these little cars here, like racing cars, and then they'll race them. We're trying to move into electric cars at the minute. At the moment, however, still petrol cars. It tends to be run by people in mechanical engineering more than robotics or automotive engineering, but some of my students have gone to work with them because they do some electronics for the car as well as the mechanical side of things. So we do contribute to that. And of course, we've got our own robotics society, as well as any other sports or society that you can think of. I'm just showing you this because next week I'm actually taking my third-year students who are just finishing their exams now to the Joint European Torus Reactor in Oxford, which is one of the leading nuclear fusion reactors, okay, in the world. It's actually finished now. And there's I don't know, maybe you know this, called an ITER. Has anyone know of ITER in France? This is a new nuclear fusion reactor that's being built that will take over this, but this is an experimental nuclear fusion reactor. So just as a celebration to finish the degree, we're going to Oxford to have a tour of this. And then after that, we're going to Oxford University to some of my contacts there to do a tour of the Oxford University Robotics Lab as well. I'm also hoping next year to have a local visit to the Composite Centre as well. So just so that if you come here, you get to see some places, not just our university, but also University of Oxford and this fusion reactor, just as a bit of fun and for you to see more things. I kind of already mentioned this really, but I'll just say it one more time about employability. Of course, I'm going to say this, of course I am, but I genuinely feel that a degree in robotics, and for this course in particular, it is as good for employability as you can really hope for, because it's got all of the latest technologies that employers like. It's got all of those numerate skills that employers like. As well as that, we have things like the engineering practice modules that we've included, so you get used to working as a team and considering a business as well. So in terms of employability, this is, I think, as a top program to work in. And you saw a few slides ago how many different places you can move to. Yeah, and we have, obviously, if you move here, we have career service to help support you as well. Whether or not you're going back to Hong Kong after or to some other country, they can give you some support. Obviously, they know a lot more about the jobs here in the UK, but they have advice. We have lots of international students from all over the world here, so they can give you some help in the latter half of your degree. That, I think, hopefully covers the main aspects of the program and the university and the Bristol Robotics Laboratory. You're welcome to send me an email at any point. I've put my email on the screen now. You can either email me directly or you can go through Kathy. And if you have any quick questions now, I can answer those as well.